welcome to this explainer. Okay, let's dive right into this. Today, we're going to talk about a massive, seemingly impossible physical limitation in the world of green aviation. But we aren't just going to look at the problem. We're actually going to map out exactly how to synthesize and master complex engineering data like this from scratch. It's a journey from a real-world, high-stakes physics problem straight into how we actively process the exact data that solves it. You know, it's probably the most intuitive question anyone could ask when thinking about green energy. Why can't we just put a massive battery in an airplane? I mean, we do it with cars, we do it with city buses, we even do it with small commuter drones. So why is commercial long-haul electric flight completely stalling out on this exact issue? Well, here's a wild fact for you. To power a standard commercial jet across the Atlantic Ocean using current lithium-ion technology, the battery itself would weigh significantly more than the actual airplane. Like, it wouldn't even be close. This is the ultimate physical roadblock for the future of aviation, and solving it really sets the stakes for everything researchers are desperately trying to overcome right now. So let's start with Section 1, the battery weight paradox, or aviation's physical limit. The battery weight paradox is basically the ultimate engineering catch-22. It's the fundamental physical hurdle where the sheer weight of the batteries needed to fly further actually prevents the plane from taking off in the first place. You see, with traditional jet fuel, an airplane burns off its energy source as it flies. By the time it reaches its destination, the plane is significantly lighter, which means it requires less lift and less thrust. A battery, however, is just dead weight. A fully depleted battery weighs the exact same as a fully charged one. You want to go a longer distance? Sure, just add more battery power. But that battery power is incredibly heavy. And that brilliantly illustrates the harsh reality in one brutal, unforgiving equation. Adding batteries to fly further literally equals preventing takeoff. You fundamentally need power to fly, but that very power source mathematically grounds you. Think about the physics involved here. The heavier the plane gets, the more aerodynamic lift you need. To get more lift, you need more thrust. To get more thrust, you need bigger motors and a much larger battery, which of course just makes the plane even heavier. It's a relentless, vicious cycle that completely rules out traditional batteries for long-distance commercial flights. The physics simply do not scale. Which brings us to Section 2, hydrogen, the surgical solution for powering long-haul routes. Now, what's really interesting about this exact phrasing from the source material is the sheer intentionality behind it, calling hydrogen a surgical solution. I absolutely love that term. It doesn't just casually say hydrogen is a good idea or a decent alternative. It implies absolute calculated precision. It means that hydrogen is capable of cutting exactly through the bloated, heavy mess of the battery paradox to fix the core underlying issue of long-haul routes without creating a dozen new cascading weight problems along the way. So, the crucial point here is that hydrogen's energy density cuts right through the weight limitation. Unlike traditional batteries, hydrogen packs an immense amount of energy into an incredibly minuscule amount of mass. To put it in perspective, hydrogen holds nearly 3 times the energy of standard aviation jet fuel by weight. It provides the massive, sustained thrust necessary to propel a heavy commercial airliner across an ocean without carrying the crippling weight penalty that would normally keep it permanently stuck on the tarmac. It completely changes the math of the entire paradox. Let's move on to Section 3, cryogenics versus solid state, the engineering crossroads. We're standing at a literal crossroads here, facing a choice between 2 extreme engineering pathways. Down one pathway, if we choose to use hydrogen, we absolutely have to master cryogenic storage. See, hydrogen might be light, but it takes up a massive amount of space as a gas. To make it fit on a plane, you have to cool it down to negative 253 degrees Celsius just to turn it into a liquid, and then somehow keep it completely stable at 30,000 feet in the air. Down the other pathway lies the dream of advanced solid-state batteries. Instead of dealing with extreme freezing temperatures, researchers are trying to reinvent chemical battery structures from the atomic ground up, attempting to pack unprecedented amounts of energy into drastically less weight. It's a fierce, high-stakes competition between 2 entirely different disciplines of extreme physics. Now for Section 4, synthesizing complex information using your source panel. Analyzing the deep, cutting-edge science of this crossroads is incredibly dense. So how do researchers, or even you, manage this absolute mountain of technical data? To dive deeper into these dense topics yourself, you really need a powerful workflow. The foundational step in mastering this complex aviation data is simply bringing your text into the source panel. Instead of drowning in hundreds of pages of aerodynamic studies and cryogenic thermal dynamics, feeding your source material into this utility sets the stage for deep, highly focused interactive learning. It's a simple, step-by-step workflow that fundamentally transforms an overwhelming engineering textbook into a structured, highly understandable format. Step 1, add your text to the source panel. Step 2, synthesize the information. Step 3, generate artifacts. Kind of think of it as a funnel. It takes the utter chaos of high-level physics, filters out all the noise, and organizes the critical data into a clear, actionable path. You move from feeling completely overwhelmed by the aviation battery paradox to being in complete command of the information. Once your material is loaded, you don't just passively read it, you interrogate it. You can instantly ask the tool to synthesize the exact physical comparisons between cryogenics and solid-state batteries that we just spent time discussing. You can command it to cross-reference their weight efficiencies, detail their respective safety protocols in high-altitude environments, or project their long-term energy outputs. And it does all of this instantly, basing every single insight strictly on the text you provided. You basically become the director of the research.
Finally, let's look at Section 5, Generating Study Artifacts with the Studio Panel.
From this panel, you can generate concrete study artifacts instantly. If you're a visual learner, you can generate video overviews that seamlessly map out this massive shift in propulsion tech. You can create highly detailed mind maps that visually connect all the disparate engineering challenges of the battery weight paradox, literally linking the thrust issues directly back to the dragon weight issues. You can instantly produce executive briefing docs, detailed study guides, and get direct citations. It essentially takes the incredibly heavy lifting out of organizing the data so your brain can focus entirely on actually understanding the physics. And here is the absolutely most vital part of this entire synthesis process. Every single answer points directly back to your text. When you're dealing with complex, high-stakes topics like the future of global aviation, thermodynamics, and cryogenic engineering, accuracy is quite literally everything. You cannot afford a hallucinated formula or a fabricated statistic. By providing direct citations, this tool grounds every generated artifact, every node on your mind map, and every paragraph in your study guide directly in your original source material. No hallucinations, just synthesized, verifiable facts. We've walked through the crushing physical limits of the battery weight paradox, the surgical, high-density solution of hydrogen propulsion, and the extreme engineering crossroads we face today. But more importantly, we've covered exactly how to synthesize that dense, overwhelming data using your source and studio panels to actually comprehend it. You're now equipped with both the knowledge of the physics and the analytical tools to process it. So, all